So in this video, we're going to go over the Mach 4 and the CFA3, okay? This first question says, find the measure of angle SRT. So let's go ahead and mark angle SRT. SRT is right there. So we're looking for this angle, okay? So hopefully what you can see is that, let me go ahead and erase these lines so I can see those angles because I can't see what it says there. So, I don't know whether you guys remember this or not, but we're going to talk it through. So this angle plus this angle, the remote interior angles equal this exterior angle right here, okay? So that means I can add those two angles together, the 11x plus the 56, and that should equal the 21x plus 6. So we're going to move like terms to each side. So I'm going to subtract the 11x from both sides. So that's going to give me 10x over here. And I'm going to subtract the 6 from here and from there. So that's going to give me the 50, okay? Then we're going to divide both sides by 10. So x is equal to 5, okay? Now what do we have to do with that 5? We have to put it back in. And I'm going to put it in here. Y'all see this right here? So it's asking us to find SRT, right? So those two angles, this one out here and this one inside, the red X and the black X, when I add those together, they equal 180, right? So I'm going to do 21 times 5, and I'm going to add 6 to that. So that's 110, let's see, what is that? 105, 105 plus 6, that's 111. But that's not the angle we want, right? We want the angle that's on the other side of that. So we're going to take 180 and subtract 111 from it, and that's going to give us our 69, which is our answer right here. Okay? So number 2 over here, let me close this out over here. So it says, in a parallelogram RSTU, the diagonals intersect at C. So I'm going to draw a parallelogram, and it might not be accurate, but we'll see. RSTU, and it says the diagonals, that's the diagonal 1, and this is another diagonal right here, right? Those diagonals, wow, that's a really crooked diagonal, y'all. Can't draw a straight line today, apparently. So it says they intersect at C, right? Then it says ST is congruent with RU. So we know the opposite sides in a parallelogram are congruent, right? So this is, ST is 4x plus 20 over here, and 6x plus 12 over there. So we can set those equal to each other, right? And solve for x. Then it tells us that SC is equal to, so this length right here is equal to 10x plus 1. And it's asking us for the whole length. Now we also know that these diagonals bisect each other, right? So that means this part that UC is equal to SC, isn't it? So to find the other one, wouldn't we just multiply that by 2? So let's go ahead and just solve first for our x by setting 6x plus 12. Okay, pen. This pen is giving me fits today, y'all. Equal to the 4x plus 20. So I'm going to subtract 4x from both sides. That's going to give me 2x here. I'm going to subtract 12 from both sides. So that's going to give me 8. So divide both sides by 2. So x is equal to 4. Now we're going to plug that 4 back up in there, in here, okay? So to do that, oops, wow, problems. To do that, we're going to go 10 times 4, that's 40, right, plus 1. So if this length right here is 41, that means this length right here is 41, and 41 times 2 is equal to our 82, which was our answer right there, okay? All right, the next one says triangle ABC with vertices A, B, and C is rotated 90 degrees clockwise and then dilated by 1/2 x, 1/2 y. So a 90 degree clockwise rotation, that means we're going what? From this first quadrant down to here. So that rule is going to be y comma negative x, right? Okay. So we're going to apply that rule first, and it's only asking us for point B. So we're going to pull this point B right here. So B is 4, 4. Then we're going to apply this rule to get B prime. B prime means they flip, right? So we're going to do 4, -4, okay, and then we're taking half of each, right? Because then we have that rule 1/2 x, 1/2 y, right? 1/2 x, comma, 1/2 y. So we're going to take half of both. So b double prime is going to be 2, comma, -2. That was our answer, okay? The next one says, what is the correct statement for step 5? So it says GHJIJ is a rhombus. That's given piece of information. It does say that right there. Then it says that GHIJ is a parallelogram. Well, a rhombus is a parallelogram. That's true. Then it says that GH and IJ, or JI, are parallel. We know that because it's a parallelogram, right? So that's parallel. And these are also parallel, right? Okay. Then it says that angle 1 is congruent with angle 2. So angle 1 is congruent with angle 2. So let's go ahead and mark that. Angle 1 is congruent with angle 2. Those are alternate interior angles to each other, right? Then it says the diagonals in a rhombus bisect opposite angles. So let's see if we can get a different color here. I'm going to do my green. Okay, so the diagonals bisect angles. So what does that tell us about? Doesn't that tell us that bisect means 2 equal parts, right? So that would mean that 4 is congruent with 1 and 2 is congruent with 3. That's why our answer is 2 is congruent to 3. Okay? So our next one's number 5. It says use the following information to answer the following question. Consider the following triangles. So in triangle ABC, we have that angle A is 85 and angle B is 25. So we can add those two together. 85 plus 25. That would be, what is that, 110? Yep. And we're going to subtract that from 180. 180 minus 110 is equal to 70. So that means the measure of angle C equals 70. So that's what we're going to do for all of these. Add 85 to 60. 85 plus 60 is 145. And we're going to subtract that 145 from 180. So for this angle, we're going to get 35 degrees. So this is ST. So this is going to be the measure of angle T. And this one is going to be, what did I say? 35, right? Okay. And then our next one, 85 plus 70, that's going to be equal to 155. So we're going to do 180 minus 155. And 180 minus 155 is 25. So this is X, Y, and Z. So X. So this is going to be the measure of angle Y, and that's going to be 25 degrees. Okay, and then it says NOP. So we're going to look for angle N for this one, right? So we're going to do 35 plus 25. That's 60. So we're doing 180 minus 60. So that means that the measure of angle N is going to be equal to 120, right? Because 60 from, there we go. And then our last one is 60 plus 25. That's 85, right? So we're going to do 180 minus 85, and that's going to be equal to EG. So we're looking for the measure of angle G, and that's going to be 95, right? Okay, so now what we're looking for is ones that match, right? So our first triangle says under the information following, consider which ones, we want to find which ones are similar, which pair of triangles are similar. So we have 85, 25, 85, 25. So let's see if we can find some that match. So we got an 85 here. Where else do we have an 85? Whoa. So let's circle some other 85-degree angles, y'all, okay? So I got an 85-degree angle there. I got an 85-degree angle there. So now we're looking for another one that has a 25, right? So 25... I don't see, let's see, 85, 25, that one's 35, right? 85, 70, 25, there's another 25, so we got 25 and 25, 85, 25. So, and then we've got, what's our third angle? 70, right? So there's our other 70-degree angle right there, 70 and 70. So that's why it's ABC and XYZ. So this next one says ABC are midpoints. Points A, B, and C are midpoints of the sides of triangle QRS. So there's some things that we can mark based on what we know. Okay, so we can say that this side AB is parallel with RC and CS, right? We can also say that, we can also say that BC is parallel with QA and AS, right? And we could say that AC is parallel with RB and BQ, right? Some other things that we could say. We could say that these three sides are congruent, right? Those three parts are congruent because remember the mid-segment AB is half of RS, right? And then here again we could say that this is congruent with these two parts. We'll do those in a different color so y'all can see it. 2 tick marks, 2 tick marks, 2 tick marks here. And then I'm going to do this last one with a different color as well. So this one would be 1, 2, 3, 1, 2, 3, 1, 2, 3. So that's what we know, okay? And it says, which theorem can be used to prove that quadrilateral ABCS is a parallelogram? So, based on what we marked, let's use purple. AB, so AB is here, AB, and what does it say? CS, C, AB, so we're going from B to, and then S, right? So, do y'all see the red in the red? So we had a red here and a red there, right? And then we've got the green and the green. Y'all see the green and the green? Green and green. That is a parallelogram, isn't it? So that's why the answer is what it is, okay? It says in figure 1 is a rhombus and figure 2 is a rectangle. Neither figure is a square. Which transformation can be used to map figure 1 onto itself and can also be used to map figure 2 onto itself? So, I think we could rotate both of them 180 degrees about their center, right? So there's the center of both. If we rotate it, if we take this one and we move it all the way down to there, we take this one and we move it all the way over to there, that's a 180 degree rotation, right? So reflection through the center of the figure that's parallel to one of the sides, that's not going to work, right? Because things are going to move top to bottom. For the figure on the figure 1, the rotation 90 degrees clockwise about the center, that's only going to move it till they're vertical. And then a reflection over one of the diagonals, that's definitely not going to work either for both, because a diagonal on over here, if we do a diagonal here, then this point goes up there, right? Okay, so that's why the answer is D. Now, number 8 says a dilation 0.2x, 0.2y. So all we have to do here is the dilation, right? So it's talking about all these points. So let's just start with our first point, which is -5. So we're going to do 0.2 times -5. That gives us -1. And then we're going to do 0.2 times our 5, and that's going to give us 1. So that's the only one that has that answer. So that is the answer. We didn't have to do all the points. So then it says, what is the length of AC here? So for this next one. So this is, obviously, these images are similar. We know that, and we're going to prove that in just a second, okay? So we have an angle, and then we have a short, so we got a short side, right? Shorter side, a long side, and then an angle. So these would perhaps be similar through side, angle, side, right? So let's go ahead and do a ratio to a ratio. So we have the 20 over the 50. This side to this side is going to be equal to, and it's asking us to find AC. So we're going to say AC over our 30, right? So we're going to cross multiply. So that's going to be 50 AC. It's going to be equal to 20 times 30. So that's going to be 50 AC is equal to 600. And 50 goes into 600 12 times, right? Divide 50 into 600 and you get that AC is 12. The next one says which similarity congruent, why this moved, but which similarity or congruence postulate or theorem lets you compare JKL to MNO? Well, first of all, we know it's not congruent, right? So it can't be this one and it can't be this one. The other two have the similarity statements on it, right? And so what do you see? We see one arc at L and O, right? And then we see two arcs at J and M. So that's why it's angle, angle, okay? This next one, number 11, says choose the best answer that describes whether the two triangles are congruent or similar. So we don't have any measures, okay? So we can't really say, but we can mark what we have. We have that this shared side is congruent, right? So do you notice that we have one tick on the left, one tick on the right for a pair of sides, and we have two ticks, CD and BD, and then we have AD is congruent to AD. So that's why this is side by side, 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 side. It can't be HL because we don't have a right angle symbol. Now, truthfully, choose the best answer that describes whether the two triangles are congruent or similar. They are both similar and congruent, okay? So then the diagonal of, so actually, truthfully, both of these answers would have been true, okay? And then the diagonals of the square LMNP intersect at K, find LNP. So it's asking us to find LNP. This angle right here, LNP. So it's asking us to find that angle right there. Well, this is what you should know about. This is a right angle, right? And then what do the diagonals do in a square? They bisect that angle, right? So if we got 90 and we divide it by 2, that is 45 degrees. Okay, that's why the answer was 45. On the next one, let's see, maybe, whoops, went too far. So this says choose the best answer that describes whether the two triangles are congruent or similar. So again, I'm going to look at AC and I'm going to compare it to FE. Okay, so that would be 12 over 30. That reduces to be 6, goes into both. This is 2/5, right? Now, if we get the same ratio for the other one, then we're good, right? We have an angle between them. So then I'm going to compare BC to DE, okay? So when we do that one, I'm going to put a line here. We get 24 over 60, and both of those are divisible by 12, so that's going to be 2/5 as well. So because we got the same ratio for both and we have an angle between them, that's why it's side, angle, side, because we got 1, arc, and then 2, 2. There's a ratio there, right? To measure the distance across a pond, a surveyor locates points A, B, C, D, and E as shown. What is AB to the nearest meter? So we want to do little triangle, big triangle here, guys, okay? So notice we have this side CE over here over the whole side of the big triangle, okay? So we're going to actually compare triangle CDE to triangle CBA, okay? So that's what we're going to do. So we're going to go CE over what? CA. Y'all see that? So that's going to give us 4 over this whole distance right here. We're going to add those two together. So that's going to be 12, right? So when we add these two together, it's going to be 12. Let me change that color. This right here, the whole distance of that whole side is 12, right? So that's 4 over 12. And then we're going to set that equal to our little triangle again. So we have DE, right? So we're going to set that equal to DE over what? Look where DE is. DE, BA, right? Over BA. Okay, so DE, BA. So DE was 5. And BA is what we're trying to solve for. AB, right? BA, AB, same thing. Okay? So we're going to cross multiply. So this is going to be 4 times. I'm going to change this to AB since that's what it's asking us for. And set that equal to 12 times 5. So that's going to be 4AB is equal to 60. How many times does 4 go into 60? Divide 4 into both. So that's why AB is equal to 15. All right, for our last one here, we're going to do the side opposite the angle compared to the side that's the side of the triangle. So we can do 4 over 2. We could do this 4 over that, or you know what, let's just do it the way it looks. So we could do 2 over 4. So 2 over 4 is equal to, again, we did the end, right? We did the end over the side, so we're doing the end over the side. So we're going to do 4 over, and then it's CE, right? So again, we're cross multiplying. So this is going to be 2CE is equal to 4 times 4. I think all of y'all know that's 16. And 2 divided into 16 is going to be 8, right? So CE was equal to 8. Okay? All right, now we're going to go over the CFA, the last CFA. So this is our CFA3A talk, okay? So on this one, let me go ahead and go. So it says in the diagram, complete the following sentence. So here again, this is going to be our C. This would be A. This would be B down here. So we're going to go A squared plus B squared equals C squared. So this is going to be 19 squared plus B squared equals 25 squared. We're going to do, this is going to be 625 and 19 squared. Let me turn on my calculator here. 19 squared equals 361. And that's plus B squared. So we're going to subtract the 361 from both sides. So B squared is going to be equal to 625 minus 361 was 265. Wait, did I do that right? Let me do this again. 25 squared minus 19 squared equals 264. 264, and it says the approximate length, right? So we're going to take the square root of 264 is about how many feet? So we're going to take the square root of 264, and that's going to give us 16.24. This was going to be equal to 16.24. So if it says approximate, we're just going to put the 16, right? All right, so number 2 over here, Caroline leaves her house and walks north 6 blocks. So that's 6. She turns and heads east 8 blocks, right? And then it's saying, what's the shortest distance between Caroline and Maddie's house? So that would be the hypotenuse, right? So we're going to go 6 squared plus 8 squared, and that's going to be equal to our C squared, right? So that's 36 plus 64. That equals C squared. That's 100 equals C squared. So we're going to take the square root of both sides. So C is equal to 10. Okay, then this next one says, what is the length? Let's see if I can roll this up, y'all. What is the length to the nearest unit of the diagonal WS? So WS is right here. So WS is right there. So all we have to do to find the length of that is draw us a right triangle, right? Because we're just looking for, okay, the hypotenuse of this right triangle. Okay, so there's my right triangle, because that's what we're looking for, right? So we have a length, a height of 1, 2, 3. And we have a width of 1, 2, 3, 4, 5, right? So what is the length to the nearest unit? So this is going to be 5 squared plus 3 squared. So that's going to be equal to my x squared, right? So that's going to be 25 plus 9 equals x squared. So that's going to be 34, right? Equals x squared. So if we take the square root of that, that would have given us 5 point, let's see, square root of 34, 5.83, right? And it said to round it, right? So that's why I got it 6 units, okay? Which defines the best approximation of the perimeter of a square whose diagonal is 10 centimeters, okay? So we got a square, and the diagonal is 10. And remember, this is a 45, 45, 90 triangle, right? Because you got a right angle there, right angle here, right angle here. These would both be 45-degree angles, yes? Okay, so we got a leg, a leg, a leg, and a leg. So if we got one formula for a 45, 45, 90, right? It's h equals L square root of 2, and we have that this is 10, and that's equal to our leg times the square root of 2. So we're just going to divide this by the square root of 2, right? So when you divide 10 by the square root of 2, you get 7.07, okay? So this is equal to 7.07, but it's asking us for perimeter, right? Perimeter. So that means we got 4 sides that are the same, right? So we're going to multiply 4 times this, and that's where our 28.4 comes from, okay? All right, the next one says, use the diagram to complete the following sentence. The area of 2 squares is given, okay? So if the area of this square is that means our sides are the same, right? These sides are the same. So wouldn't we just do the square root of 400? That means that's 20, right? So this is 20 and this is 20. All right, and then we could take the square root again of 841. Square root of 841 is equal to 29. So that means this is 29 and this is 29. This was 20, right? This was 20. So if we have the hypotenuse is, so we could actually just subtract these, couldn't we? Because 29 squared is going to be equal to 20 squared plus our a squared, right? So that's going to be 841 equals 400 plus our a squared. That's going to be 441, right? And because it's asking us for the area of the third square. That would be a squared. So that would be, yeah, that's the area because a squared is the area, okay? Use the lengths of the sides of the triangles to answer the following questions. It says, which of the triangles are not right triangles? So if we square 10 squared plus 12 squared, does that equal? Remember, this is always going to be our C. Our biggest one is going to be our C. So that's going to be, well, let's do it this way. I don't know why it's doing that. It's picking up my hand. So we're going to do 10 squared plus 12 squared. Does that equal 15 squared? That's what we're doing for all of these, okay? So I'm going to do this on my calculator. 10 squared plus 12 squared. That is 244. And 15 squared is 225. So that would not be equal. So that's our answer right there. First one. Nice. I like it when it's the first one, don't y'all? All right, so here's the next one. Use the information to answer the following questions. Oh, so this one's like our test was, right? So it says DEF, where angle D is 50 and 65. So we're going to add these together. 50 plus 65, that's going to be, what is that, 115? And we're going to subtract that from 180. 180 minus 115 is equal to 65. So our third angle here is going to be 65. We're going to add 55 to 70. That's 125. Okay, so this is our third angle here. And this is going to be 125. So we're going to subtract that from 180. 180 minus 125. So that gives us 55 for this third angle. I think I need to change my point, y'all, to make it smaller. Okay, and then we've got 55 and 65. 55 plus 65. That's 120, so we got 120 there. And when we subtract 120 from 180, we get 60 here, right? And then 50 plus 55 is 105, right? 105, so we subtract 105 from, so that's going to be 75. So now we're just trying to match the angles, right? So it says, consider if triangle ABC is 50 and 75, so 50 plus 75 is 125. So these two was 125. We're going to subtract that from 180. So that was 55, okay? So we're trying to find another triangle that has a 50, a 75, and a 55. A 50, so we got 50 and 50 here. 50 and 50. And and 50, there's another 50. Okay, so those three match there. Then we need 65, right? So, no, 75. So we got 75 here. Do we have another 75 up here somewhere? There's a 75 right there. And I don't have any other one that has 75. And then let's choose green for our third color. So now we've got the 55, right? And the 55 right there. So there's not another one. There's a 55 and a 55. But we need all three check marks, right? Indeed. Okay. So the only one that had all three check marks was M and O. So that's why it's triangle M and O. Okay. So our last one says use the figure to answer the following questions. If AC is parallel to DE, which of the following justifies triangle ABC is similar to triangle DBE? So we do know that these ABC and DBE, right? DBE is a little triangle. So we know that the angles are congruent, right there, because they are shared in both, right? Then you also know that this angle is parallel with this, or is congruent with that, because they're corresponding angles, right? So you only need two, yes? You don't need all three, okay? But we could actually say that third angles are similar as well, but we only need one more.